Hello everyone, hope you all are doing well. Today we will start our new topic, that is solubility product. Before understanding solubility product, we will understand about equilibrium, that what is equilibrium. There are two types of equilibrium. One is molecular equilibrium and second is ionic equilibrium. Talking about molecular equilibrium is obtained by a covalent bond where we are having non-metal and non-metal make a product. Like we are having two examples over here. One is of H2 plus I2, it's making 2Hi, and second is 2NO plus O2, that is making 2NO2. Okay, after that we are having here more examples, that is H2SO4, sulfuric acid, C6H12O6, glucose, NH3, that is ammonia. And after that covalent bond is without IUM. I have written by mistakenly over here that with IUM, but it is without IUM. Like ammonia, in the end of ammonia there is no IUM, so that's why this is called the covalent bond and it's make a molecules. After that, talking about ionic equilibrium, in ionic equilibrium it is basically ionic equilibrium is a compound that is obtained by a ionic bond where we are having one metal and one non-metal, that is making a product. Okay, here we are having HCl, AgCl. Here Ag plus and plus Cl. One is metal and one is non-metal. It's making a ionic equilibrium here as a product. So we can understand that how which one is molecular equilibrium and which one is ionic equilibrium. After that we are having here more examples like NaI, K2SO4 and many more. After that ionic bond will always be remain with IUM and that will call a compound, and these are called the electrolytes. Electrolytes is same as ionic equilibrium. Like in electrolytes we are having two charges, one is positive and one is negative, that is passing through the electricity. So same over here, here we are having NaI, one is metal that is plus and one is non-metal that is negative. Okay, after that talking about the electrolyte, firstly we will understand electrolyte, then we will understand more about the ionic equilibrium. Let's start electrolyte. In electrolyte we are having partial charge of electrolyte and complete charge of electrolyte. What is mean by partial charge of electrolyte and complete charge of electrolyte? Basically complete charge of electrolyte having light metals, light metals having strong electrolyte, and strong electrolytes are present in first group, and in first group we are having hydrogen, lithium, Na, potassium, rubidium, cesium, francium. Okay, these all are from first group and these are light metals, and light metals are strong electrolyte. So these are complete charge of electrolytes. Talking about partial charge of electrolyte, the heavy metals, that are those are very heavy, these have a weak electrons. Like weak electrolyte, one is strong electrolyte and second is weak electrolyte. Now weak electrolyte, like we are having Ag, Au, like gold, we are having iron, these all are our heavy metals. So these are having weak electrolytes, that is partial charge of electrolyte. Now after that let's move towards upward again. Here we are having example of AgCl and Ag plus Cl. AgCl is we are having a weak electrolyte. So here I have written We, weak electrolyte, that doesn't dissolve or ionize completely. When it will not dissolve or ionize completely in water, so some of its part will dissolve and some will not dissolve in water, in aqueous solution. Okay, so that is weak electrolyte because there is a equilibrium because of water. And in strong electrolyte, when we are dissolving in water, it's totally dissolved. Like we are having 100 NaCl. Okay, so the totally 100 NaCl will dissolve like 100 Na plus 100 Cl. Like we are having 100 NaCl, so it will totally dissolve, like nothing will remain, just zero will be there on both sided. So it is called the strong electrolyte that total dissolve the aqueous solution, that total dissolve in a water. But we will work on solubility product of AgCl, which is not totally dissolved in a water, which is in a equilibrium position, like dissolve and undissolved in water both. So molecular equilibrium is written as Kc, like we are writing the value of Kc. So molecular equilibrium will write same as Kc, that is Kc is equal to product upon reactant. Okay, but ionic equilibrium is written as solubility product. Why solubility product? Because weak electrolyte is dissolving and undissolving in water, so it's soluble. So that's why we will work on weak electrolyte of ionic equilibrium. Let's take a weak electrolyte of an ionic equilibrium. So here is a solubility product that is represented by Ksp. Here we are having solid in the form of AgCl. When we just dissolve it in water, so we have Ag and Cl, metal and non-metal. Here we have written aqueous solution means dissolved in water. So how we will write it in a Kc position? We will write in a Kc form, like Kc is equal to product upon reactant. Okay, as the reactant, as the product, this is a product. Ag plus Cl is a product, it is soluble, this product is soluble. That's why some of it is dissolved and some of it is undissolved. So when it is soluble, the concentration of undissolved AgCl, the concentration of undissolved is reactant, will remain same. Therefore we will write it in the form of Ksp, solubility product. Now what happened here? It's dividing. When it will go there, it will multiply. So Kc multiply AgCl. AgCl is a K that we are having constant, means remain same. So in the place of that we will put K, and other will remain on their position, that is Ag plus and Cl minus. Kc dot K will make here solubility product, that is Ksp. It means that the reactant, the product is soluble, like the Ag plus Cl is soluble. The concentration of undissolved AgCl remains same. The concentration of this will remain same, but this will be soluble. Therefore the solubility product is equal to Ag plus and Cl minus. Just we are writing it in the form of, like previously we are writing in the form of Kc, that the ratio between product and the reactant, like we were writing Kc, ratio between product and reactant. But over here we are writing in the form of solubility product, that we are having solubility product, that is Ag plus and Cl minus. Now simple definition or simple statement of it is, to understand, is it is a type of dynamic equilibrium that exists when a chemical compound is in the solid state. Now AgCl was in solid state. In a dynamic equilibrium it exists when a chemical compound in the solid state. This was a chemical compound, it was a compound, so it was in a solid state, is in chemical equilibrium. This was happening, what, it's dissolving in water, so it means it was in chemical equilibrium. And after that it says that is in chemical equilibrium and with solution of that compound, like it is in a chemical equilibrium also, but we are also having a solution of that compound. So we are writing that solution in a form of solubility product. Hope you understand about solubility product with the help of ionic equilibrium and electrolyte. Now basically, to find the solubility, like to write a solubility product, to write any reaction in a solubility product, we are using ionic equilibrium. But in ionic equilibrium we are using weak electrolyte. I also told you how you should know that it's a weak electrolyte or it's a strong electrolyte. Heavy metals are weak electrolytes and it's a partial charge, and light metals are strong electrolytes that are in first group of periodic table, that is complete charge of electron. Hope you understand today's lecture. If you have any question, do comment. I will reply you as soon as possible. Till that, Allah Hafiz. Thank you so much. Don't forget to subscribe my channel.